Hey guys, today we are going to look at samples, and so today's going to be a lot of discussion and talking through what makes a good sample, what makes a biased sample, and how to collect data to get the best information. So we're going to have lots of vocab in here. So first off, a population. That's a group of people or objects that you want information about. A parameter then is a numerical characteristic of a population. So a parameter is a fixed number like mu or sigma, but we don't know its value. A sample is just a subset of the population, and we're going to talk about a few different types of samples that we can get to collect data. Statistic is a numerical characteristic of a sample. So the mean is a numerical characteristic. We often use a statistic to estimate an unknown parameter. An inference is the process of reaching a conclusion due to known facts or evidence. Hopefully that's a word that you've heard before. You've made inferences probably in your English class, or perhaps in science, conclusion based on some evidence. Quantitative data and categorical data. Quantitative data is data that can be measured. It's numerical, numbers. So the mean, the median, the standard deviation. For example, the weight, length, time, test scores. That's all quantitative data that you can collect. Categorical data is descriptive data. A person's gender, car model that they own, yes or no questions, pass, fail. That's categorical. Things that we can put into categories versus numerically measure. All right, so there's another population sample definition up there at the top, just as a reminder. So a sample then has 4 different kinds of samples that we are going to discuss. So the first one is a self-selected sample. Members of a population can volunteer to be in the sample. So that would be like in this classroom if I said, okay, raise your hand if you want to take this survey. Anybody that raised their hand would be part of that self-selected sample. A systematic sample has a rule that's used, such as selecting every other person. In the classroom, I might say, okay, every other row is going to take this sample or take this survey. You would be a part of a systematic sample then. Convenient sample is easy to reach. Members of a population are selected, such as those in the first row. A random sample, no rhyme or reason here. Each member of a population has an equal chance of being selected. One thing I'm doing in this set of notes is I'm giving you problems that are in the notes, but then I'm also going to give you a problem that's not in the notes. So you can pause the video, you can try to answer on your own, and then come back when you feel like you have the answer, and I'll go over it with you. So a manufacturer wants to sample the parts from a production line for defects. Identify the type of sample described. You should have this in your notes. The manufacturer has every 5th item on the production line tested for defects. So that would be a systematic sample. Every 5th item, that's a rule there. Whereas the manufacturer has the first 50 items on the production line tested. That would be convenience. First 50 items, and then he's done. So that's a convenience sample. Alright, so here's one that's not in your notes. Pause this, try it on your own, and come back when you're ready. So a sports writer wants to survey college baseball coaches about whether they think wooden bats should be mandatory throughout college baseball. Identify the type of sample described. So the sports writer contacts only the coaches that he has cell phone numbers for in order to get quick responses. Well, again, that would be convenience if he's only using who he has a cell phone number for. It's a convenience sample. Sports writer mails out surveys to all the coaches and uses only the surveys that are returned. Well, you are volunteering to return them. That is a self-selected sample. All right, 2 types of samples. We can have a biased sample or an unbiased sample. We really would like to have an unbiased sample when we're collecting data. An unbiased sample is representative of the population you want information about. A biased sample overrepresents or underrepresents part of the population. So, a magazine asked its readers to send in their responses to several questions regarding healthy eating. Tell whether the sample of responses is biased or unbiased. Well, it doesn't tell us exactly what magazine this is, but usually magazines target a certain type of population. So if this were a fitness magazine, you probably would have people tend toward more healthy eating. So I would say that this is probably a biased sample, especially because it's a self-selected survey. They're choosing to respond about healthy eating. So I would say this was biased. Try another one of these. The manager of a concert hall wants to know how often people in the community attend concerts. The manager asks 50 people standing in line for a rock concert how many concerts per year they attend. Tell whether the sample is biased or unbiased. Explain your reasoning. So, again, I say this is biased because they're already at a concert, so of course they go to concerts. Whereas if you were outside somewhere else, you may get somebody that has never attended a concert in their life. So better ways to probably get a better sampling than right outside his own concert hall. All right, the owner of a company with 300 employees wants to survey them about their preference for a regular 5-day, 8-hour work week or a 4-day, 10-hour work week. Describe a method for selecting a random sample of 50 employees to poll. This is something that I would like for you to write down, and I want you to discuss in your group when you come back to class. So describe a method for selecting a random sample of 50 employees to poll. How would you get an unbiased survey of this? Here's another one for you to try. You're a member of the prom committee. You want to poll members of the senior class to find out where they want to hold the prom. There are 324 students in the senior class. Describe a method for selecting a random sample of 40 seniors to poll. This is another one you can discuss in your group. How would you make sure that it's random? How would you make sure that you represented the senior class well and didn't just get all of your friends who may all have the same values about prom that the entire class may not hold? All right, margin of error gives a limit on how much the responses of the sample would differ from the responses of the population. Margin of error is something you see a lot when dealing with different polls that are done, especially around election time. You will see margin of error. You'll see that some candidate has a 43% chance of winning with a margin of error plus or minus 4%. Well, that could mean they're at 47% or they're at 39%, and that's a huge margin of error. So the formula here is highlighted for you. When a random sample of size n is taken from a large population, the margin of error is approximated by this formula. So it's plus or minus 1 over the square root of the number of responses. This means that if the percent of a sample responding a certain way is p, expressed as a decimal, then the percent of the population that would respond the same way is likely to be between p minus 1 over the square root of n and p plus 1 over the square root of n. So, if we are looking at this one, in a survey of 1,535 people, 48% preferred brand A over brand B and brand C. What is the margin of error for the survey? Well, margin of error is plus or minus 1 over the square root of the number of people, so 1,535. So then it's approximately plus or minus 0.0255, or about plus or minus 2.6%. Give an interval that is likely to obtain the exact percent of all people who prefer brand A. Okay, so that interval means that if we know that 48% preferred brand A over brand B and C, then we need to do 48 minus 2.6 and 48 plus 2.6. So 48 minus 2.6 is 45.4%. 48 plus 2.6 is 50.6%. So somewhere between 45.4 and 50.6 is probably the percentage of people who prefer brand A over brands B and C. Here's another for you to try. In a survey of 1,011 people, 52% said that television is their main source of news. What is the margin of error for this survey? Again, pause this if you want to try it on your own, and then we will come back and do it together when you are ready. So the margin of error would be plus or minus 1 over square root of 1,011. So that's approximately plus or minus 0.03 or plus or minus 3%. So then give an interval that's likely to contain the exact percent. So 52 is our middle number. 52 minus 3 is 49%. 52 plus 3 is 55%. So hopefully you're seeing that the more people you have, the smaller the margin of error becomes. So you want to include more people in your sample so that you don't have as big of a margin of error when you're trying to make conclusions. Okay, so I'm going to kind of work backwards on this one. This says a state legislator conducts a poll to determine if the voters want to increase their property tax to make highway improvements. How many people were surveyed if the margin of error was plus or minus 3%? Well, we would say plus or minus 0.03 is 3% as a decimal is equal to 1 over plus or minus 1 over the square root of n. I'm not going to worry about the plus or minus right now, but I'm going to multiply then both sides by square root of n, so I get 0.03 times the square root of n is equal to 1. And then I'm going to divide both sides by 0.03. So the square root of n, 1 divided by 0.03 is 33.3 repeating. If I want to get rid of this square root, I need to square it and square it. So n is about 1,111 people. Here's another one for you. A polling company conducts a poll for a U.S. presidential election. How many people did the company survey if the margin of error is plus or minus 5%? So plus or minus 0.05 equals 1 over square root of n, and again that's plus or minus here as well. We're going to drop the plus or minus, multiply both sides by the square root of n, so 0.05 times the square root of n is equal to 1, divide by 0.05. So the square root of n is equal to, and 1 divided by 0.05 is 20. So then I need to square both sides. So n is equal to 400. So that's choice C here. 400 people if you have a 5% margin of error. Alright guys, that's all I have for you. If you have questions, come in and see me. Otherwise, I will see you in class.